A&Pers. This is Dr. Jones checking in. This is A&P1, lecture test 4, video 14, covering page 15. So at the top of page 15, which for me looks like this, the heavier the load, the longer it takes for movement to begin. And you can see this here at stimulus, a small load movement begins pretty quickly. Excuse me, intermediate load takes longer, and the heavier the load it is, the longer it takes before the movement begins. Can the Z lines be pushed apart? No. So how does a muscle return to its resting length? Well, we have said before that the return to resting length is passive. And passive means that you do not burn ATP to do it. At least this muscle isn't. So how does that happen? There are a number of ways. There are elastic forces. The elastic forces inside the cell are the organelles. They take up space, and so they can kind of push the cells back apart. And the extracellular, outside the cells, elastic forces are the tendons. The tendons have a bit of elasticity to them. When you have them contracted, they kind of want to relax the elastic forces. And also, the biggest thing is the opposing muscle contractions. I've used the word antagonist before. We'll use it again now. The biceps and triceps are antagonists. The bicep flexes the elbow, but it cannot extend the elbow to return the sarcomeres to resting length. So what happens is the triceps brachii contracts, and that returns the biceps brachii to its resting length. Now that my triceps is done contracting, how do I return it to resting length? Well, basically by my biceps. These pairs of antagonists work together to work against each other. So how that works. Just like the hamstrings flex the knee and the quads extend the knee. So they're antagonists. And also gravity. Gravity helps pull your arm down when you're done with your bicep curl. Okay, and then now section 10.7. It's 7 now, they changed it. We're not covering this section, however. There are some basic concepts here that you 100% need to know. Also, you should come back to this section next semester, at the beginning of test 5 for biochem, because this is the best biochem general overview. We don't need that right now. What we need is what we're about to discuss. ATP is made in which organelle? The mitochondria. 90 some odd % are made in the mitochondria. There are ways to make them outside of the mitochondria. It just doesn't make as much ATP. Okay. Muscle fibers use a lot of ATP, so we expect them to have a lot of mitochondria. And I do want you to notice that a lot is 2 separate words. So, college educated. A lot as one word is not a word. Okay. Not an English major, however, grammar matters. Y'all college educated now. Would extranuclei help provide energy? And no. Just no. What do nuclei have to do with energy? Jack squat. Why are skeletal muscle cells multinucleate? Because the nuclei contain the DNA. The DNA is the instructions for all the proteins, including the enzymes, and the Muscle cells need a lot of structural proteins and also enzymes, so they have lots of copies of the nuclei to have lots of copies of the recipes for the genes to make the proteins. Is there anything in energy about any of that? What makes the energy? The mitochondria. You got it. Okay. Explain how ATP is involved in the contraction cycle. Detaches across bridges. How else is it involved in muscle contraction? The calcium ion pumps that pump the calcium back into storage in the sarcoplasmic reticulum. All right, that's what you need to know of section 10.7. Section 10.8, force, is the maximum amount of tension produced by a muscle or muscle group. So in English terms, this would be what we call strength. And endurance is the amount of time an individual can perform an activity. So this is what we would call stamina. So force and endurance are strength and stamina. And the types of skeletal muscle fibers, and we have slow fibers and intermediate fibers and fast fibers. And I don't think I have this chart in the, no, I don't have this chart in the PowerPoint. Okay, I'm gonna go down the list. So we're gonna talk about slow fibers. So the size, the diameter of the slow fibers is small. So we're here, we're at slow fibers. The fatigue resistance is high. What does that mean? If it resists fatigue, fatigue is tired, and it resists fatigue. Resist means it doesn't. So it doesn't get tired very easily. Okay. So fatigue resistance is high, so it has lots of stamina. And then the color on the slow fibers is red. It is a darker color for two reasons. One, because the myoglobin content is high. And I don't know if we've talked about this word yet. We kind of glossed over the fact that skeletal muscles have an energy reserve, and this myoglobin stores oxygen. Myo here means muscle. In the muscle. It stores oxygen in the muscle, myoglobin. And so that's part of what makes the slow fibers red. And also because they have a dense blood supply. They have lots of arteries and veins. So that contributes to the red color of the slow fibers. Mitochondria, lots. That's one word, lots. Because they make lots of ATP. And the glycogen reserves, glycogen, please note, is a sugar storage molecule. And the glycogen reserves and the slow fibers is smaller. So the intermediate fibers, the size is intermediate, and I put a quote here to show that it's the same. And fatigue resistance, intermediate. The color is intermediate, which is pink. The myoglobin content is low. The blood supply is intermediate. The mitochondria are intermediate. And the glycogen reserves are not intermediate, they are high. Okay. And then the fast fibers, and this is what we have the most of, the fast fibers are larger. And you can see this in the picture here. The fast fibers have a larger diameter than the slow fibers. Like twice as big on that picture. They have a low fatigue resistance, which means they do not resist fatigue, which means they get tired fast. The color is white. The myoglobin content is low. Blood supply is scarce. Few blood vessels. Mitochondria are few, and the glycogens reserves are large. And the book adds that they have densely packed myofibrils and powerful contractions. So fast fibers have lots of force, but low endurance. So they have strength, but not stamina. And then the slow fibers have low force but high endurance, so less strength and more stamina. The slow fibers are aerobic because they use lots of oxygen, and the fast fibers are anaerobic where they use less oxygen. Okay, so we will talk more about that in the next video when we talk about where do you find slow fibers and fast fibers in a chicken. Can you work it out? All right, so this was AMP1 lecture test for video 14 covering page 15. The education must go on. Dr. J.